Hi everyone, it's Mrs. Marcellus. I'm here again with Pythagoras today. Hey Pythagoras, in our last lesson we learned about ratios. Today we're going to learn about rates. Rates are a special kind of ratio. How does that sound? Today's learning objective. The students will find a unit rate by writing a rate as a fraction and simplifying it so it has a denominator of 1. Sounds interesting, doesn't it? I think this is a really handy thing to know. Today's vocabulary word is unit rate. A unit rate is a special ratio comparing two quantities with different types of units. A unit rate always has a denominator of 1, and a unit rate must have a label to be complete. Getting an up-close look at our audience out there, are you, Pythagoras? Do they look like they're ready to try some problems? Okay, let's take a look at some examples. In our first problem, Tyler picks 45 oranges in 5 minutes. Express this as a unit rate. The first step in finding a unit rate is to write the original ratio. Our original ratio from the problem is 45 oranges in 5 minutes. And just like regular ratios, unless we're finding a unit price, the item that comes first in the expression will go on top, and the item that comes second will go on the bottom. We will have 45 oranges over 5 minutes. The next thing we need to do is simplify our ratio so that it has a denominator of 1. In order to do this, we must divide 5 minutes by 5, because 5 divided by 5 equals 1. Whatever we do to the denominator, we must also do to the numerator. So that means that we need to divide both the top and the bottom by 5. You will always divide both the top and the bottom by the denominator. Once we do this, we have our unit rate. Tyler can pick 9 oranges in 1 minute. This is one way to write the answer, but there are some other acceptable ways. You could also write the answer as 9 oranges per minute, and you can simplify minute to be MIN because that's a common and standard abbreviation. Or you could write 9 oranges / minute, which implies 1 minute. Let's try another example. Emily types 455 words in 7 minutes. Express this as a unit rate. Again, we will start with the original ratio. Since we need the denominator to be 1, divide both the top and bottom by 7. This will give us our unit rate of 65 words a minute. You could also write this as 65 words per minute. You could write 65 words / minute, or in this case we could use the very common abbreviation 65 WPM. If it's a well-known abbreviation such as words per minute WPM or miles per gallon MPG or miles per hour MPH, it's okay to use that. However, if it's something like the number of hot dogs eaten per minute, we couldn't use HDPM because that wouldn't be a common abbreviation that everyone would know. In our next example, we have the Griswolds. If they travel 411 miles in 6 hours at a constant speed, how many miles per hour is Mr. Griswold driving? The first step is to set up the original ratio, so we begin with 411 miles over 6 hours. Then we need a denominator of 1, so we will divide both the top and the bottom by 6. You may be noticing a pattern that each time we divide by the denominator. Another way you can approach the problem is to simply think the top number divided by the bottom number. We can divide 411 by 6 and still get the same result. Once we divide by 6, we find that Mr. Griswold is driving at 68.5 miles per hour. It is okay when you're working with unit rates to have a decimal inside your fraction. Whenever you're finding the unit price, we are finding the cost per unit. When you're asked for unit price, the price of the item will go on top and the item unit will go on the bottom. Sometimes word problems are not written in this order, so it's important to know that it's price divided by unit. 4 deluxe hanging baskets cost $88. What is the cost per basket? Since we were finding the cost per basket, we know that the cost or the price goes on top and the number of baskets goes on the bottom, even though that's opposite of the order that they're given in the word problem. The first thing we will do is write our ratio of $88 for 4 baskets. Since we need a denominator of 1, we will divide by 4. Once we divide by 4, we learn that it costs $22 for 1 basket. Let's do some comparison shopping. The price for 1 dozen eggs is $1.80. The price for 18 eggs is $2.88. Which is the better buy? In order to compare prices, we will need to find the unit price for each package of eggs. Let's start with the package of eggs that costs $1.80 for 1 dozen. We start with the original ratio, putting the price over the number of eggs, and then we divide by 12. $1.80 divided by 12 gives us a result of 15 cents for each egg. Next, we find the unit price for the package of 18 eggs for $2.88. We start with the original ratio, the price over the number of eggs, and then we will divide by 18. After you divide $2.88 by 18, you find that each egg costs 16 cents. In the first package, each egg costs only 15 cents, and in the second package, each egg costs 16 cents. Therefore, the first package of 12 eggs for $1.80 is the better buy. Well, Pythagoras, that concludes our lesson for today, but we will be traveling to Megalo Value Mart next week to apply the comparison shopping skills we just learned. Bye for now!